Hi there. This is a video on chapter one in your textbook. The main learning objectives are to explain the objective of statistics as a discipline, to distinguish between lots of different vocabulary, for example, parameters versus statistics, qualitative data versus quantitative data, different types of ways we measure data or different measurements of data, uh, the difference between an observational study and an experimental study, and the differences between simple random samples, convenience study, a voluntary study, stratified, systematic, and cluster. So we have a lot of vocabulary to introduce the idea of statistics. It is its own little language, and I would strongly recommend keeping like a little place in your notes just for vocabulary and their definitions. It can sound like a foreign language if you're halfway through the course and you haven't really absorbed all of these new vocabulary words, and there's a lot of them. So having a source where you can just quickly look up what stuff means, you will find very thankful that you did that starting from the beginning of the semester. All right, well, let's get into these different objectives. All right, so the first one, explain the objective of statistics. Well, the way I try to explain statistics is that a lot of things in life just have an element of chance or randomness. And I'm not just talking about like rolling dice or cards or any of those kinds of things. I'm just talking about, just like measuring a pen. I can measure a pen, and I can determine the length of that. And that's great. But if other people measure this exact same pen, they may not get the same number as me, depending on the tool they use or the way things line up with their ruler versus my ruler or whatever. It may be close, but it won't always necessarily be exactly the same. So there are some differences involved, and that comes with all kinds of things in life that we're trying to measure, right? Anything that involves measurement, whether it's natural grown things like apples, or whether it's human made things, all kinds of measurements have randomness or variation built into them. So, given this fact, can we make some predictions about these events that have randomness built in? And so the answer is yes. Statistics is the discipline, is the course that says if we use a sample of events, we can make some smart predictions about a population. And we could even possibly give a margin of error about whether our predictions are significant or not. So that's the big TLDR of what statistics is, and of course, with some examples, it'll become much more clear. I'll give you some examples, in fact, today. All right, so there are a bunch of things that are going to be called parameters, and a bunch of things that are going to be called statistics, and they really want you to know the difference between those two. For various reasons, there are formulas that work for parameters, and there's formulas that work for statistics. So we have to kind of know which formula to use, and they oftentimes sound similar. So what's a parameter? A parameter is a measurement of the entire population, whatever that population is going to be, like U.S. adults, or all the apples in a store, or all the kids that attend this particular school. When we're measuring a population, we can talk about the size, the average, the range of values. There's lots of things we can measure about a population, and all those measurements are called parameters. And we can do the same kind of measurements about a sample of the population. So maybe not all U.S. adults, but maybe 1,000 from each state or something like that, or maybe not all the apples in the store, but let's say let's say the first three crates that we come across, we can measure those. Again, we can measure sample size, sample average, the range of values of the sample, but those things, because they are a portion of the population, are all called statistics. So if you say the size is 20, if someone says the size is 20, you need to ask yourself, is that size a population size? So it's a parameter, or is that size a sample size? So it's a statistic. So you really have to keep track of what is a sample, a measurement of a sample, and what's a measurement of a population. All right, next set of vocabulary words. This is vocabulary day, right? chapter one is all about vocabulary. We're going to categorize data as categorical data, which is oftentimes called qualitative, or we're going to categorize data as numerical, which is sometimes called quantitative. And these words look and sound kind of similar, but you might notice that the first four letters of the categorical version end with an L, qualitative. And for the numerical, it's an N, quantitative, right? So qualitative versus quantitative. You could use categorical and numerical. They mean the same thing, and they're easier to distinguish. So what example, what is in fact categorical versus numerical data? So categorical or qualitative data is usually not numerical, and it describes them, usually categories like, the different colors of Skittles or something like that, red Skittles, blue Skittles, whatever different color Skittles there are. You're describing the different types of Skittles. The reason I say usually non-numerical is because sometimes numbers don't really have a meaning in a sense. They're just categories. For example, my cell phone has the area code 510. That's the category of phones around where I live. My office phone has a area code of 925. And so because all the phones in that area have 925. So those are essentially categories, the category near my office and the category near my home. But those numbers, 925 and 510, the two numbers I mentioned, they don't really have any specific meaning. I'm not going to say like my office number, my 925 number is much better or greater or whatever than my other number 510. The numbers don't really have any numerical significance. They're just identifying categories, the Pittsburgh category versus the Oakland Berkeley category, which is where I live. So anyway, so that's why I say usually non-numerical, right? Usually is carrying a lot of weight here. You'll have to sort of look at the numerical data and say, is this really measuring numbers, or is it just representing categories? On the other hand, numerical data are quantitative. Oh, this should say quantitative. It looks like I did a copy and paste and didn't change things. So let me do that now. Quantitative. Yeah. As much as you proofread stuff, you sometimes still find mistakes. So numerical data, which is quantitative with the N, that's the numbers. That's always numbers, always numerical, and we can measure it, right? The numbers mean things, right? The measurements mean things. All right, so that's the first set of vocabulary words. Ready for some more? Okay, here you go. We're going to identify the different types of measurement. Math people call these levels of measurement, low to high. I don't know if I subscribe to that belief, but there are different kinds of measurements. So the first kind, and again, they're going to ask you questions about these, and you're going to, is this nominal data? Is this ordinal data? And you're going to have to say yes or no, or pick between some of them. And so just having the definitions is just going to be handy. Nominal data is a type of categorical data, qualitative data, and it has no meaningful order. It just has categories like people's names or colors of whatever Skittles or whatever you're doing, right? They're just categories without really any ordering that we can put in them in. I guess you could technically put names in alphabetical order, but let's just pretend that there's no real natural ordering that you can do. Right? I mean, you could do ordering names in lots of different ways. It doesn't have to be alphabetical. All right. Ordinal. Ordinal is the second measurement or type of data. And it is also a type of categorical data. And it is essentially things that can be ranked. It doesn't have to be numbers, but I'll give you one number example, one non-number example. So if you have a poll and you're saying like rank how your whatever service was from a scale from 1 to 10, one being the worst, 10 being the best, that is a ranking in categories, but 10 is not 10 times as good as one, and it doesn't really have that kind of meaningful thing. But it is ordered. We could say 10 is better than 9 and better than 8, stuff like that. Maybe your highest degree earned, maybe you made it through 10th grade, maybe you made it with a college degree, whatever it is, the highest grade earned is another type of ordinal data because it's essentially a category and you can order them, right? So finished grade 10 is not as far as getting a college degree. So we can order them in a natural way. Okay, so now we get to two types of numerical or quantitative data, interval data and ratio data. And they're pretty similar with one little difference. Math people will say it has to do with a natural zero. I find that definition a little cumbersome and hard to grasp a little bit. So what I tend to say is that interval data, the numbers can be ordered and the differences are meaningful but not proportional. And what I mean by proportional is like for temperature, if it's 50 degrees outside, it's pretty darn cold. If you double 50 degrees, you get 100 degrees. That's not twice as warm as 50 degrees. It's much more warmer than 50 degrees. 50 degrees is really cold. You need a jacket and stuff like that. 100 is not twice as hot as 50. There's no real proportionality of a temperature. 1 degree temperature, 3 degree temperature. 3 degree temperature is 3 times 1 degree temperature. They're both freaking freezing, right? So it just doesn't work out with proportions, which are multiplying one compared to the other. Standardized scores, SAT scores, if you get like a 300 on a score versus 900 on a score, it's not like 3 times as many questions you got correct. It's just a way of numerically ordering those things, but the differences matter. 900 versus 300, it's definitely a 600-point difference. We can order them. It makes sense to look at the subtractions, the differences in temperature or SAT score, but not the multiplication. So subtraction makes sense, multiplication doesn't make sense. So subtraction, good, multiplication, not so. Or I'll just say bad, just to make it easy to remember. So ratio data is the subtraction and the multiplication are both good. So for things like age and price, subtraction is good. You're 3 years older than your sibling, and multiplication is also good, right? So if the price is $10 versus the price is $5, the $10 really is twice as more expensive as the $5, right? So the multiplication is also good. I don't know if that little chart here is helpful or more distracting than anything, but that's the idea between the two different types of numerical data, interval data, and ratio data, where you have things that are proportional that make sense versus things that are proportional that don't make sense. All right, we got just a couple more things to do for this video. One is the vocabulary of an observational study versus an experimental study. So they're both studies. You're both trying to observe some subjects, some people, some things, something that you want to write down numbers for, you want to measure. An observational study is the subjects of the study are just observed, and you don't try to affect the outcome in any way. You don't try to affect the individuals to try to change anything. You're just observing what's going on. For an experimental study, you're going to choose at least some of the subjects. Could be a few, it could be all of them, whatever, and you're going to do something that affects them. The thing you do that affects these subjects is called a treatment. And so one example of a treatment could be like a medicine. You could literally give someone a treatment for some ailment. Maybe you give it to some people and not other people to try to see if there's a difference in the reaction of this treatment. That thing you're doing to the people that you give the pill to, the treatment to, is attempting to affect them. You can even like yell at them with strong language, and that definitely can affect people. So it doesn't have to be like an actual item that you give to them, but yelling stern words at someone definitely is an attempt to affect that person. So yelling would be an experimental study because at least some of the people are going to be affected by the thing that you introduced, which is yelling. So yelling would be the treatment that tries to influence or affect the subjects. All right, so observational study, experimental study, two things to keep track of. Last but not least, we have a long list of types of studies. So here are some common types of studies. There are many more types of studies, but we're going to stick to these ones primarily in our course. I'm going to put me over here, I guess. Okay, so I have a type here and an example of each one. So a simple random sample, this is what we try to do. This is what gives us the most confidence that our predictions are going to be accurate. A simple random sample is where you have a population and every member of the population has an equal chance of being selected to be part of the sample. For example, every student at LMC has a student ID number. Right? Every person has one student ID number. No two students have the same ID number. So suppose you had a computer that had all the ID numbers in a list, and the computer randomly chose 20 of those ID numbers. Every person, every student at the college has an equal chance of being selected. And so that sample of 20 students would be a simple random sample, would be an SRS of the population of students at LMC, because each of those 20 students was randomly selected, they had an equal chance of being selected. And the people that weren't selected also had an equal chance of being selected. They just randomly were not. So that's what we strive to do, a simple random sample. The other types of samples I'm going to be showing you aren't the gold standard. They're not as great, but sometimes, it's very difficult to do a simple random sample, and we have to do things that, are the best we can manage at the time. And then we have to sort of deal with the consequences of how that changes the accuracy or the predictability of our data. So the next type is called a convenient sample, and you're just doing things that are convenient for you. You're looking at members of the population that are easy to choose for some reason. So the example I gave here was people at a local park at noon. So you have some park nearby, you go there at noon and you ask people questions, or you do something, you yell at them or something, if you want to do an experiment as opposed to an observation. And then you write down some results of whatever you did. That's just convenient for you. Even if the population were park goers, people go to the park, like at noon, you're not going to get a representation of the population of people who go to the park. Specifically, not everyone who goes to the park has an equal chance of being selected, because people go in the morning and they're not going to be there at noon because they're at work or school or something, and so not everyone has an equal chance of being selected. But it was convenient for you to go there and get your sample. A voluntary sample, which is this third type right here, a voluntary study, is where people opt in, right? So only people that could be selected are people who want to be selected. I gave an example here, an Instagram poll. You do an Instagram poll, the people who respond to the poll are the people who want to respond to the poll. And maybe lots of people have lots of opinions and things, but they didn't respond for whatever reason. They didn't see it or they didn't feel like it. Or whatever reason. The only people that you have access to are the people who opted in. The next one is called stratified. I'm actually going to talk about stratified and cluster, which is the fourth and fifth ones here. I'm going to be talking about a little bit together because they're similar, and students have typically get them a little bit mixed up. So a stratified, the population, whatever population you're talking about, is divided into meaningful categories. So you take the entire population, break them into categories. Then a simple random sample from each category is taken. So my example would be categorized by gender. So you get each genders, and each gender, we're going to choose 100 random subjects, right? So that would be a stratified sample, because we're dividing into categories. And then for each category, we're taking a SRS, a simple random sample, in this case, 100 from each of those categories. Cluster also divides the population into meaningful categories. So again, for a cluster and for a stratified, you're taking the entire population, breaking them into categories, whatever makes sense for you to do. The difference with cluster is that we're only taking a random sample of categories. So if there's 5 categories, maybe we take randomly 2 of those of the 5 categories. So we're doing an SRS not of the people, the population, we're doing an SRS of the categories. Once we take an SRS of the categories, then every single person in each category is going to be selected for the sample. So for my example, again, we're going to break the whole population into categories. Suppose we categorize by age. Suppose that's my example right here. Categories by age versus any other categorization. I just chose different things just to help explain, things that would be less confusing to be the same thing. But you just have to categorize things. Suppose I categorize by age. I choose 10 random ages. I choose 10 random categories. And then for each of those 10 ages, I choose everyone. So suppose our population is adults in California. So California adults is our entire population. And then we break all of the adults into 21-year-olds, 22-year-olds, 23-year-olds, 24-year-olds, all the way up to however old we can find the Californians, right? So we have all sets of people, but they're categorized by age. So of these categories, maybe there's 100 different ages we got here. We're going to take 10 random categories from those 100 ages. Now, suppose we choose age, 23 and age 35, and age 92, right? So we have different categories, different ages that we've chosen. Then we ask every single 23-year-old, every single 35-year-old, whatever numbers I chose, we're going to ask everyone who fits in the category. That is called cluster sampling. All right. Hopefully, I did an okay job explaining the difference between stratified sampling and cluster sampling. And lastly, we have systemic sampling. So we take the population, we organize it in some order, or maybe it's already organized in an order, but we just definitely have to have an order. And then the subjects are chosen at an agreed upon specified interval. So an example of that might be you go to a store, and every 5th person that walks into the store, you're going to do your experiment on. Maybe you ask them a question, or maybe you yell at them, or whatever, right? So whatever you're going to be doing, every 5th person you're going to be doing. So it's a systemic or systematic sampling method or systematic study, because you're going to take the population of people who go to the store, and then on a chosen specified interval, every 5 people, you're going to be doing your study. You're going to be doing your experiment or observation. All right, so those are all of the vocabulary words and the different things to keep track of in chapter 1, and of course they appear later on in chapter 2 and 3 and 4. So that's why we're introducing them now, so you can kind of get an introduction to the different types of vocabulary, and then sort of try to keep track of them as we charge through the course. So once again, the purpose of this video here was to help explain the objective statistics, to distinguish between parameters and statistics, between a parameter and a statistic, to categorize data as either categorical or numerical, to identify the different levels or measurements of data, to differentiate between an observational study and an experimental study, and explain the difference between common types of studies, specifically a SRS, a simple random sample, a convenience study, a voluntary study, a stratified study, a systemic study, or a cluster study. All right, well, please reach out if you have any questions or if I can help with anything, and I hope you have an enjoyable day.